Alright, make sure you have out your toolkits and you're ready to take notes. Today we are talking about adding and subtracting in scientific notation. So basically what I'm going to do is just a few examples so you can get an idea of how we do these types of problems, and then we'll do some examples tomorrow in class. Alright, so we'll start with adding in scientific notation, which is really simple. If I had two numbers in scientific notation and I wanted to add them together, it's easy as long as their exponents are the same. Okay? Because that's just how many times you're moving the decimal place. So we're going to do the same for both numbers, so we can just add them. So we can do 2.56 plus 6.964, and we add them together. There we go. Oh, my bad. That's supposed to be a 5, not a 6. There we go. Okay, so we add them together, and then we just tack on that 10 to the third that we were using in both before, and we're done. We've added those numbers in scientific notation. Okay, so now subtracting in scientific notation. Also basically the same exact thing, only this time we're subtracting. And remember, if the exponents are the same, then we are good to go. So we just subtract 9.49 minus 4.863. That should be a 0. There we go, we've subtracted, and then we add the same end amount that was there before. Now, like I said, as long as the exponents are the same, we're good. It gets a little tricky if the exponents are not the same. So for example, if I had 4.12 times 10 to the 6th, and I wanted to add it to 3.94 times 10 to the 4th, I'd need to make it so that our exponents were that doesn't really look like 2 to the 4th, does it? Let's fix that. There we go. I'd have to change it so that the exponents were the same. Now you can change this one to be 10 to the 4th, or you can change this one to be 10 to the 6th. It doesn't make a difference, but I'm just going to change this one to be 10 to the 4th to make it, just to make a decision. So let's just talk a little bit about what this means. So this number is actually needs to have its exponent or its decimal moved over 6 places, right? 1, 2, 3, 4, 5, 6. So that's the real number. And if we wanted to make it 10 to the 4th, we only want our decimal to move 4 times. 1, 2, 3, 4. So our decimal should be here if we want it 10 to the 4th. So we would need 412 times 10 to the 4th plus 3.94 times 10 to the 4th. Now we can do what we did before. We just add them. Did I do that right? Yeah, I did that right. Okay. Now, what we end up with is 415.94 times 10 to the 4th. Now, this is not in correct scientific notation. Our decimal point needs to be here. So now we need to move the decimal point back 2 more places, which actually makes it 4.15 times 10 to the 6th. Now, we'll be practicing this in class tomorrow. This was just to give you a taste of what it'll look like. Something important to remember is I expanded the number out in order to move the decimal to show you, but when these numbers, these exponents up here are very big, you won't be able to expand the number out to move the decimal. So it's important that you understand how this exponent affects where the decimal is, so that you can do these changes like this without having to expand it. So make sure you have that copied down into your toolkit, and answer the questions here, and we'll practice this tomorrow.